Assalamualaikum and good day to everyone. My name is Muhammad Haikal Faiz Bisman. My number metric is CF240127. I'm from section 5. Today, I'm going to present for my personal assignment BFC 21702 Geotechnic 1 for semester 1 2024-2025 session. First, what is soil classification? Soil classification is a systematic method for categorizing soil type based on their physical and chemical properties, which helps in understanding soil behavior for various applications. Soil is a complex mixture of minerals, organic matter, water, and air, and its characteristics can vary significantly from one location to another. By classifying soil, we can predict how it will react under different environmental and load conditions, which is essential in fields like agriculture, geology, and civil engineering. There are various soil classification systems, each tailored to different needs. Two primary systems are the Unified Soil Classification System (USCS) and the H2 Soil Classification System used for highways. These systems group soil based on attributes like grain size, plasticity, and texture, helping professionals decide on soil suitability for construction, drainage, and farming purposes. Soil classification is foundational for projects involving soil stabilization, foundation design, irrigation planning, and environmental impact assessment. Coarse-grained soils are a category of soil that primarily consists of larger particles, typically those with a diameter greater than 0.075 millimeters, 75 microns. These soils are characterized by their relatively larger grain size compared to fine-grained soils such as clays and silts. Coarse-grained soils are further subdivided into two main types. First, gravel. This consists of particles larger than 2 mm in diameter but smaller than 75 mm. Gravel can be classified as either fine gravel, which is 2 mm to 4.75 mm in diameter, coarse gravel, which is 4.75 mm to 75 mm in diameter. Second is sand. This includes particles with diameter between 0.075 mm and 2 mm. Sand can also be classified into fine sand, 0.075 mm to 0.25 mm in diameter. Medium sand. Medium sand is a 0.25 mm to 0.5 mm in diameter. Coarse sand, 0.5 mm to 2 mm in diameter. Coarse grained soils are often used in construction projects such as foundation, roadbeds, drainage system, and other applications where strong, well-draining material are needed. Fine-grained soils are soil composed of very small particles, primarily silt and clay, which are less than 0.075 mm in diameter. These soils are categorized by their particle size, cohesiveness, and plasticity characteristic. Fine-grained soils typically fall under two main classifications. First, silts. These particles are finer than sand but coarser than clay, with diameter between 0.002 mm and 0.075 mm. Silt particles are generally non-cohesive and have a smooth texture when dry, but they can become slippery and lose strength when wet. Second, clays. These particles are even smaller than silt, typically less than 0.002 mm in diameter. Clay soils are cohesive and have high plasticity, meaning they can be molded when wet. They tend to retain water, shrink when they are dry, and expand when they absorb moisture, which makes them more reactive to changes in moisture levels. Fine-grained soils are often challenging in construction because of their high moisture sensitivity, tendency to retain water, and potential for expansion or shrinkage. Engineers must consider this factor, especially in foundation, slopes, and other load-bearing structure, to ensure stability and prevent soil-related issues. Okay, next, this is an example. Coarse grain soil is gravel. Yang ni di mana saya dapatkan gravel berhampiran dengan rumah saya, di mana saya menjumpai batu di kawasan tepi rumah saya, dan saya cuba untuk merasai dan dia punya saiz tu dengan menggunakan tangan saya. Dan saya cuba juga untuk menyiram air dekat atas batu gravel dan melihat macam mana air itu melalui di antara celah-celah batu tersebut. Okay, next, we go to coarse grain soil, which is sandy soil. Okay, saya menjumpai tanah sandy soil berhadapan dengan rumah saya. Saya mengambil cangkul dan untuk korek tanah tersebut, dan saya mengambil tanah tersebut menggunakan tangan saya dan saya merasai bagaimana tekstur dan kekasaran ataupun kelembutan tanah tersebut. Dan saya juga cuba untuk menyirami air di atas tanah tersebut untuk melihat bagaimana tanah tersebut dapat mampu untuk menyerap air yang sebegitu. Jadi lepas saya dah menyiram air atas permukaan tanah tersebut dan tanah tersebut pun telah menyerap air itu, saya cuba ambil tanah yang telah diserami dengan air itu untuk merasai tekstur tanah tersebut. Maka saya dapati tanah tersebut mampu untuk mengekalkan kelembapan air itu dan mampu untuk menahan menakung air itu dengan banyak. Okay, next, we go to fine grain soil, which is clay soil. Okay, selain daripada sandy soil, saya juga jumpa fine grain soil, iaitu clay soil dekat berhadapan juga dengan rumah saya. Saya jumpa, saya mengambil cangkul dan saya cuba menggali tanah tersebut, dan saya juga merasai yang tekstur tanah ini lebih lembut daripada yang sandy soil tadi, dan saya menyirami air di atas kawasan permukaan tanah clay soil ni, dan saya dapati clay soil ni lebih mudah untuk menyerap air berbanding dengan sandy soil tadi. Dan selepas saya menyirami air, saya tunggu untuk tanah clay soil ni untuk menyerap air itu. Jadi selepas itu saya mengambil tanah tersebut untuk merasai bagaimana kelembutan tanah clay soil ni selepas dia sudah menyerap air. Jadi saya rasa yang clay soil ni lebih lembut berbanding dengan sandy soil setelah kita sirami air di kawasan permukaan dia. Lastly, conclusion. Soil classification helps us understand how soils behave for breeding, farming, and environmental needs. By grouping soil based on texture, makeup, and physical traits, we can predict things like how well they support weight, drain water, or support plant growth. Systems like the USDA soil taxonomy and the Unified Soil Classification System (USCS) give us standards for identifying and comparing soil types. This knowledge guides better decisions for construction, agriculture, and land use and conservation, promoting sustainable soil use. That's all from me. Thank you, everyone.